Yep, and that goes over to the right. Now, one thing that's a little odd here is this is data 0, 1, 2, 3. And I expect these 4 to be the data lines. Now, again, my eyes might be just screwing with me. Oh, they are. This line here takes a little jog underneath this part and goes to someplace else. So the right line, I'm guessing, hooks to right, which would make a lot of sense, and then read goes back to someplace else. Because on these memory modules, you have your address coming in, and then write or read. You know, if write isn't low, it's a read, more or less. Or actually, chip enable would be the read pin, pin 8. Let me go beep that. It may be connected and I just can't see it. So, assuming this is right, this is read. 1, 2, 3, 4, 7, 8. Nope. I probably should trace that guy back right now, just so I know where the heck it pops out. So he comes here, he flips around, he goes underneath, God, I almost want to say he hits that pad right there, but I don't think he does. Because that would be really odd. Nope, he doesn't hit right there. Now, there's a bunch of test points right here, so let's see if we get lucky. Nope. 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 Oh, this might be a royal pain in the patootie to trace. Now the other thing it could be hooked to is an address line. But I kind of doubt it. Now I assumed it was hooking it. Oh no, it just loops around that hole. And it's 1, 2, 3 up. 1, 2, 3 up. 1, 2, 3. Haha! All the way over to here, which then goes all the way back again. But I bet it hooks. I bet it hits some pin on the mic. Ooh, ooh, ooh. Right there, pin 1. Yep, it goes all the way back to the Z80. Makes sense, because this is what's generating both the address data and all the read-write control lines. So eventually everything makes its way back there. So what else do we have left on this guy? On the top side, these were all the control lines heading off this way. So they're done. On the bottom side, I got these 2 pins here and a few pins out here. Now there should have been a clock. This is well before the day of the integrated oscillators. So somewhere inside this U, or one of the pins on this UART, is the clock coming in. Pin 20. So we're going to have to chase him back and just see where he comes from. It's not Super critical, we know, but you know, kind of nice to know what the hell's going on. Oh, there's a lot of pins. RXD, that's the receive. Pin 9, TXC. Oh, that's the transmit. So let's go see what pin 9 does. And just work our way through this thing one pin at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4 over. 9 hooks to 4 over. Oh, RX control and TX control hook to each other, and then hook to, I thought I saw it going over here. $74.93, which is, it's a 4-bit counter. Huh. So when I say 4-bit counter, it takes a clock pulse in, and every cycle of that clock pulse, it increments the I/O pins. Let me see if I got a picture of that guy. And it's just, you know, pulse in, you know, all lows, that's count 0. Next pulse in will give you all lows and a high. Next pulse in will give you all lows, high, low. Next pulse in, low, low, high, high. So it's just binary counting up. Now, why these TX enables are tied to that guy, I could not tell you at this time. That's a little bit of an odd connection. I would not have expected that. Unless there's some state engine going in here where, I don't even want to go there right now. So, anyways, this connects to there. So, what's the next pin on this UART? We'll come back to the guy in a minute. Pin was right, which hooked to right. 11's chip select. So what chip select is sort of like the master enable. So you can poke the read and write bits with the right address all you want, but until that chip select is decoded, it's not going to do anything. Pin 11. 1, 2, 3, 4, 5, 6, 7, 4 from the end. 1, 2, 3, 4. So he goes to next two. Go these two vias here, which then plop over to this side. And go to a 138, which makes sense. You know, this is the address decode. Now I just gotta figure out where they go. Okay. One chip select went right here. The other, the next pin up, which isn't a chip select, I need to go look and see what it is. but he went right there, pin 1. So let's make sure that those are both decoder outputs, 138 decoder outputs. 138. Oh. Pin 1 is an address line. To that guy. Yeah, that runs all over the place. So pin 1 is an address line coming back into this guy, where the other one comes off of 1, 2, 3, 4, 5, 6, 7, 8, 9. Pin 9. So pin 9 is a standard decoded output. But the pin 1, that's got me a little curious. CD. What is CD? Is there a pin description? Reset. Okay. Control data. So they just took an address line and wired it straight into that, so that whenever that address bit flips, so that might be the least significant bit, whenever he flips, he selects the control or data registers inside the UART. So it sort of makes sense that it was wired straight back into an address line, if that address line was a very, like the least significant bit. No reason to manually decode it because it's always just going to be a 1 or a 0. Read pin 14 RS ready. Goes absolutely nowhere. That's an easy one.